Welcome to this lesson here. We're going to be taking a look at how to use multiple triangles in order to solve problems involving right angle triangles and using them to kind of come up with one side to figure out a second side. And so I just want to do a little bit of review of remembering what we need when we talk about right angle triangles. And we're looking at kind of those basics of right angle triangles right now. And so first things that we always need to do is label our triangles based on the angle that is given. So you'll notice in this case here, we have angle theta up on top there. That's just an angle that either we know what it is or we might need to find what it is. And so our adjacent side is going to be the left-hand side there, that vertical piece. And then our opposite is going to be our bottom side. Okay, hypotenuse always stays as the longest piece. With these sides labeled, we can use our ratios sine, cosine, and tangent in order to solve for a missing side, a missing angle, or whatever else we might, or whatever we need for this triangle, whether it's multiple sides or multiple angles that we need to come up with. These are the ratios we're going to use. We can use them kind of as a function as well in order to come up with an answer. Now remember that these ratios are only useful with right angle triangles, and so it's important that we can only use them with a right angle triangle. Another one we can only use with a right angle triangle is Pythagorean theorem. Okay, so this one here is, again, a squared plus b squared equals c squared. So if we have two sides, we can find a third one. We might need to use this as well. But remember with this one here, we need to label the triangle a little bit differently. And so we're going to have A, B, and C, where C is our hypotenuse, and A and B are the two sides that we have. All right, this is what we need to know, okay? And we have to remember that right angle triangles are the only thing that we can use these ratios and Pythagorean theorem on. So what happens when we're given this big triangle, okay? And we're asked to find what is the measure of CD. There we go, that side right there. Okay, first of all, the big triangle that you see there, not a right angle triangle, okay? It has been broken into two different right angle triangles, okay? And for this here, we need to figure out what our two triangles are, okay? So I have this blue one here that I'm gonna show you, and I have a purple one, okay? So I've labeled them as two individual right angle triangles. We need to figure out what are our two, what they are. You'll notice here that the side that we're given, we're asked to find, is on the purple triangle, but the purple triangle doesn't have enough information in order to solve. Okay, but that's okay because the blue triangle does have information to find a matching side. Okay, the one that where the two triangles meet, that's a matching side. So we could actually use that information to solve the purple triangle, which is really good. And that's kind of the process that we're going to use to solve for multi-triangle problems. All right, what do we need to do once we know what our triangles are? Well, let's label the triangles, okay? The blue triangle, I'm going to label in red here, the hypotenuse, adjacent, and opposite. It's all based on the 28-degree angle there in the corner, and so we're going to use that as our reference angle. The second one, the purple triangle, I'm going to label in green over here, and I have labeled the adjacent, opposite, and hypotenuse of it. And you'll notice that the opposite side of the purple triangle is equal to the opposite side of the blue triangle. That's awesome. That's really going to help us out. Also be aware that that 14 centimeters on the bottom is only for the blue triangle. It's not for the entire thing. Okay, so we need to know that it's only for the blue triangle, which does help us out in some ways so that we don't get confused by the whole thing. Okay, so that arrow just represents just the bottom of the blue triangle. In fact, the adjacent side. All right, so let's measure this out. What we're going to do, so in a question like this, what we need to do is solve one side first, and then potentially, and most likely, use that answer to find the next one. Or we might have to find two different numbers and then add them together, or two different numbers and subtract them. And we're going to go through some examples like that in a little bit as well, as we go through the lesson and trying to solve. So I'm going to start with the blue triangle because I have enough information for that. I know the adjacent side, I know the angle. So because of that, we're going to find the opposite side of the blue triangle first. Opposite and adjacent, so we're going to use tangent. You can definitely try this on your calculators as well. you should get an opposite side that is 7.44 and then a whole bunch more decimal places. Sorry, we'll go that way. That follow it. Okay. The thing is with this number here, it's not going to be an exact number that you're going to use most likely unless we are careful with our calculators. But we also don't want to just round it to 7 because that's not a super accurate number. We want to try to keep it as accurate as possible as we work through and try to solve it. So what I'm going to do and what I did when I created this question and created this answer is I kept this number in my calculator. So don't erase it yet. Keep the number in there, 7.44, and then a whole bunch more decimal places. Okay, keep that in your calculator, and then we're going to use that going forward. So I'm going to put that number in there. Okay, just I rounded it there, but I'm going to keep the 7.44 with a whole bunch of decimal places in my calculator. All right, now we know the opposite side of the blue triangle, which means that the opposite side of the purple triangle is exactly the same. Okay, so the purple triangle also has a measurement of 7.44 centimeters. So we know the opposite side now, and we can find the hypotenuse. We're going to use sine for that. Now you'll notice here that I have the 7.44 centimeters in my equation, but in my calculator, I'm keeping the 7.44 and repeated, or not repeated, but continuous decimals in there. So I'm going to start with that, 7.44, just have it in my calculator, times 1 divided by sine of 70, and I'm going to get an answer of 7.92. Now, when we do that there, I'm just going to quickly go through this on my calculator as I'm talking here. If you round it to 7.44, you're going to get the same answer of 7.92. Once you round it, let's just quickly go through here. No, sorry, I did that wrong. There we go. And then divided by sine of 70. So what's going to happen is I'm just getting the numbers exact here. If you round it to 7.44, you're going to get an answer of 7.917, which rounds up to 7.92. But if you keep the 7.44 and a whole bunch more decimal places in, you're going to get an answer of 7.9216 and then some more. So which again rounds to 7.92. But it is a little more accurate and it might change things farther along, or it might round to a different number. So it's always good to try to keep as many decimal places as possible, and sometimes we can do it by just putting it in our calculator. In my class, I'm not going to be super strict on how many decimal places you keep in there, but I would recommend like 2, 3, 4 or more decimal places at least before you come up with your final answer. All right, so there's our answer. Okay. So that side is going to be 7.92 centimeters. We've gone through 2 different steps in order to solve our question here. Okay, so we have to find one answer first and then use it to find the next one. Okay, let's do some examples here. I'm going to put the first example up on the screen. This is a classic example that I love using. I use it over and over. I'd like you to pause the video, work through this example, try to find the measure of length P. Okay, so find the length of measure P. If it really helps, think of this triangle here. You're looking for that bottom piece. Okay, so that's what we're looking for. I'm going to get rid of that for the time being. Pause the video, try to solve for it, and then start it back up and we will see how you did. All right, welcome back. We're going to try to solve for side P, or the length P, and that is from the point, just where is it down here? I'm just trying to figure out how this camera is working. The point down there to about halfway across, not exactly halfway, but we want to try to figure out what that length is. Now, like I showed before we paused here, this is kind of that triangle that we're dealing with, and you might notice and hopefully notice that this is not a right angle triangle in any way. Okay, it's not in any way a right angle triangle, so we cannot use our ratios on this triangle. We can't find one of the sides and then use it to find that second side. It does not work that way. Okay, so you can't do that. What we need to do is we need to start by looking at this entire right angle triangle and figuring out what is the adjacent side to this triangle. So that's going to give us the entire distance, okay, the entire distance from the right angle to the point, and then we'll find the shorter distance and subtract it from there to figure out what P is. We have the opposite side. We have 28 degrees as being our angle, so we're going to use tan in order to solve for our adjacent, and we're going to come up with an adjacent side of 24.07 meters. Okay, so that's that entire distance all the way across, which includes P and the shorter triangle there by the 48. Second step that we need to do in this case here is we need to use this triangle right here. So we're going to use this little blue triangle that we have. We're going to find, again, the adjacent side to this triangle using the same numbers, except the angle has now changed, and it's going to give us a different adjacent side of 11.53 meters. So now we know that the full thing is 24.07 and the short piece is 11.53. And then to figure out that other piece, the P, we are going to subtract. And so P is equal to 12.54 meters. So hopefully you're able to get that. Again, like I said, this is a classic example. It could very well be on a test, an exam, or an assignment. Okay, so it's just a classic example of find the full length, subtract the shorter piece, and then that gives you the remaining piece. Okay, here's another one. In this case, we are going to try to find angle ZXW. Okay, that is this green triangle, the bottom angle. So let me see if I can figure out how to point there. That bottom angle right there. Okay, you can hopefully find it there. If you need a little more hint, that one. Okay, let's find that angle. And pause and come back when you get your answer. Okay, let's take a look at how to find this angle. Now, looking at this green triangle here, you will notice that, again, it is not a right angle triangle. So we cannot use our ratios on this triangle exactly. What that means is we're going to have to look at it in two steps. So let's get rid of the green one there. Let's get that out of the way. And let's pull up our first big right angle triangle. This big right angle triangle, we can find that angle X there, that whole thing, okay, which will technically be angle ZXY. Okay, so we're looking for the angle ZXY. And so that we're going to find that whole thing. Notice that we have the two sides. So YZ is 7 and XY is 7. And if you're really quick on the ball here, you'll get that that was 45 degrees. So that angle right there is 45 degrees. Okay, that whole thing. Now to figure out that top piece that we're looking for, we're going to use this bottom right angle triangle and subtract that angle away from 45 degrees. But first we have to find it. So again, we're going to use tangent in order to solve for it. And we're going to get an angle of 29.74 degrees. Again, keep a few decimal places in every situation. The 45 was exact. And now to find the missing angle, or the one we're trying to find, we're going to subtract and get 15.26 degrees, or angle ZXW is equal to 15 degrees. Again, angles we often round to the nearest degree, okay, which works, I would say, really well. All right, okay, so far so good. Do we get 100%? I hope so. If not, again, it's about going through practice and hopefully understanding all of that practice. Let's do a word problem. Okay, so again, I'll have you pause the video, try to draw out a diagram which makes sense for it. If you're unsure, you can always watch me go through the diagram and then pause it after that to try to solve. But try to draw a diagram, see what it looks like, and then solve for what is the height of the tree. And if you're unsure, there's the tree. Okay, welcome back. Again, like I mentioned before, if you want to watch the diagram and then try to solve it without my help, gladly do that. Here's a description of the diagram. We have a tree. We have Mr. Barkman. Now, you'll notice this guy has hair. I do not. Shucks. So maybe I didn't get an exact picture of myself. But what we're talking about here is we're looking at this horizontal, which is 1.7 meters above the ground. So my eyes are 1.7 meters above the ground. That's the horizontal that I look at. If I look down at the bottom of the tree, it's going to have an angle of depression of 6 degrees. So that part is 6 degrees. And if we look to the top of the tree over here, it's going to have an angle of 47 degrees. Now we're trying to figure out this entire measurement. Okay, so the whole measurement or the height of the tree. And we know already that the bottom piece is 1.7 meters, so we have to figure out that top piece using that other right angle triangle. To do that, we're going to need to know what is this side right here, and then we're going to use that side to figure out the remaining height of the tree from my eyes up. So again, if you want to now use this diagram in order to solve, go ahead and pause the video again. Otherwise, I'm going to go through and solve for the height of the tree. All right, we're going to use the bottom triangle first to figure out the distance from my eyes to the tree. Okay, and we're going to use tangent for that again. We have the opposite side. We're looking for the adjacent side. I know I didn't label it here. Sorry, but going through it, it's really hard to label on PowerPoint apparently. We're going to get that our adjacent side there is 16.17 meters. Again, keep decimal places. Okay, don't just leave it at 16. Keep a few decimal places. I'm going to replace that on there, so that's becomes 16.17 meters. That's how far I am away from the tree. Then we're going to use that number in order to solve for the height of the tree. So we can look at this part right here, which again is going to be the opposite side of this triangle. We have the adjacent now. We're going to find the opposite. So let's plug them in again using tan, and we get a measurement of 17.34 meters. Now be careful when you are going to solve for the height of the tree. It is not that 16.17 is not part of the height. The 1.7 is, and so we add those two together and we get that our tree is 19.04 meters tall. All right, this has been a big lesson. There's been a lot of information in here. The important thing again is to be able to draw our diagrams properly, know what pieces we're looking for, and then use one piece to find a second piece in order to solve this question. Best of luck as you work through some questions, work through some problems. And if you have questions, again, gladly contact me and we can talk through what the answers might be or what the problems that you have might be on these types of questions. Happy math. Enjoy learning.